This question is about the preparation of hexan 2-ol. So 1, 2, 3, 4, 5, 6, and all on number 2. Hexan 2-ol does not mix with water and has a boiling point of 140 degrees C. Hexan 2-ol can be prepared from hexguanine. So we're starting at hexguanine and ending up at hexan 2-ol using this method. Measure 11 centimetres cubed of hexguanine into a boiling tube in an ice bath and carefully add 5 centimetres cubed concentrated phosphoric acid. After 5 minutes, add 10 centimetres cubed of distilled water and transfer the boiling tube's contents to a separating funnel. Shake and allow the mixture to settle. Discard the lower aqueous layer. Add some fresh distilled water and repeat steps D and E. Transfer the remaining liquid to a beaker. Add 2 grams of anhydrous magnesium sulfate and allow to stand for 5 minutes. Filter the mixture under reduced pressure. Distill the filtrate and collect the distillate that boils in the range of 130 to 160. It is important to wear eye protection and a lab coat when completing this experiment. Suggests with a reason one other safety precaution for this experiment. There's quite a few that we could pick on. So we could either think about the concentrated phosphoric acid, because that comes right at the beginning, and say we would want to wear gloves because concentrated acids are corrosive. So conc phosphoric is corrosive. So that's the first thing that sort of strikes us in this method. We could talk about using a fume cupboard because the volatile organic compounds can be harmful. We're using a separating funnel here, so we could talk about periodically opening the separating funnel to relieve the build-up of pressure. Any of those would be suitable. Give a reason for adding distilled water in C and F. So we're adding distilled water. The water is to kind of wash away, to remove water-soluble impurities. Give a reason for adding anhydrous magnesium sulfate. Well, that's our drying agent. So this is to remove any remaining water that didn't get tapped off, to dry our sample. Complete and label the diagram used to filter under reduced pressure. So we've got our vacuum pump. We need to be drawing our Bucknett funnel. So it's got a flat base and then kind of funnel shape. We need to not close the funnel at the bottom, but we do need to put a bung in here so that the pressure from the pump is forcing liquid through the funnel. The funnel has a sintered bottom, bottom with holes in it. So a dotted line to represent that, and then a solid line above it to represent a piece of filter paper. So this is our Buckner funnel. If you missed your umlauts, I'm sure that would be fine. We've got a filter paper, is our horizontal piece. We've got our bung or kind of collar that stops the pressure that was going to the pump having no effect. And we've got a cross-sectional diagram, and what we need to be careful of, I'm going to do something that's wrong here and then remove it, but we mustn't draw a line here because that will seal the bottom of the funnel. So I've just removed that again. It says the most likely organic impurity, or identify the most likely organic impurity other than hexguanine. So we started with hexguanine and we were trying to make hexan 2-ol, and it says other than hexguanine, what else could we have made? Well, the issue is when we had added this water across this double bond, we could have equally have made hexan 1-ol instead of hexan 2-ol. It says, suggest one reason it could be difficult to remove this impurity. It will have a very similar boiling point to hexan 2-ol because they are position isomers. Calculate the mass in grams of hexan 2-ol. So let's just remind ourselves of our equation. Hexguanine is going to hexan 2-ol. We're starting with 11 centimetres cubed of this, and we've got a 31% yield. We've got a density of 0.678 grams per centimetre cubed. So let's work out our mass to start off with. So it's 11 centimetres cubed and 0.678 grams per centimetre cubed. So 11 centimetres cubed, each centimetre cubed is 0.678 grams. So that's 7.458 grams. Then we can do the number of moles of hexguanine. So that would, remembering that an alkene is CnH2n. So 7.458 divided by, we're going to add up 6 C's and 12 H's and get 84. So that's 0.0888 moles. Now, assuming only 31% converts, then we're going to do 0.0888 times 31 over 100. What is 31% of this? So 0.0275. And then we're going to do mass is Mr. moles. We need to add up the mass this time of hexan 2-ol, which is an alcohol, so CnH2n plus 2O. So we want to add up 6 12s, 14 1s and a 16, which is going to be 102, and multiply it by our moles, and we're getting 2.81 or 2.8 grams because it said give our answer to 1 decimal place, so it only wanted 1 decimal place, 2.8 grams.